Okay, so review of help, thank you. So let's, Vanessa made a good comment, and Shane pointed out where it went wrong over there. So let's finish the math, that's how Vanessa suggested. Here, let's find B. All right, so we have B is minus R sine. Okay, I just did it wrong here. Minus B. No, I'm wrong again.
We have to subtract. We have to subtract B is minus RB. This one is B.
Oh, yeah, right. But this would just be a plus.
So that would be some plus sign.
Gosh, why can't I see this? Okay. All right, I'm gonna let you guys help me here. R cosine minus B.
And negative R. Or you can write plus R.
Okay, plus R.
Sine negative 1. Oh, and the I, R-I, sine.
Oh, yeah. Plus I R sine. Oh, this minus.
Yes.
Oh my God. Hang on a second. Oh, I see it. Oh my gosh. Okay. Thank you. All right, so the sign of minus B is minus, so this minus, and there we have it. Okay, now it works. Whew. Like I think I told you, the hardest part of being a teacher is being human, yeah. So it's probably another mistake, huh?
No.
Okay.
I just so is it what I'm talking about splitting out functions? Or is it like?
Oh, make those, okay, yeah, so let's go back. Okay, so on using the unit symbol, let's try this. I'm going to just remind you, and I'll show you. Even and on. Let's do a quick review. I think this came up in different, a few of you are asking, and I think you're doing it different ways, so let's just remind ourselves. So an even function says that if you take f of negative x, it's the same as f of x. And I'll draw you a picture of one that comes into play right now. Here's Pat. Just extend it this way. So if I go pi over 2, pi, 3 pi over 2, and 1, and minus 1. So the cosine would look like this. So that's kind of a weird cosine, but that's about what it looks like. But let's go the other way too. So if I go the other way, so the cosine continues this direction. Okay, so notice this. So cosine isn't even, this is cosine. And notice this, if I put in an x, like right here, if I put in this value, so we'll just call this A. If I come over here to the same distance minus A, notice that I would get a different colored pen. Let's do this so we can see. So on an even function, if you put in a positive value, you would get this output. But if you put in the exact same negative value, or the same value but just it's negative, notice you get the exact same output. So even if you pick the point, say over here, like point positive B, so if you came over here, negative B, if you look at the output, you'd be at this value here, but it's also the exact same value over here. So that would be an even function. So in other words, the cosine of negative x is the same as the cosine of x. What's so funny? Are they? 1, 2, 3, oh, oops, 1, 2, oh yeah, it works even better. Thank you. There we go. There we go, that works. And then, so an odd function. An odd function says that if you take f of minus x, it's equal to minus f of x. Like that. So sine, let's take a look at sine. Sine looks like this. Up, back down to 0, goes down to -1, comes back up to 0. On the other side, though, it goes down to -1, goes up to 0, up to 1, back down to 0. So let's take a look at a random value here. Okay, so let's say I pick something a little bit above pi over 2. So I get this output here. If I put in the negative, so let's call this A. So if I come over here to minus A, notice that what I'm getting is just the negative value of this. It's at the same height, but it's the negative value. So that's what an odd function does. So you can think of them on the unit circle, or you can just think of the pictures like this. Either one works. Does that explain that? And all of that is because what I also wanted was this. I write the polar form of Z bar, it was RE. Notice this. Okay, so if you look at it this way, it's not so obvious. But if you come up to this stage here, we have the same R's, we have a plus I form. So the only thing that changes is the angle, so we can write minus I. Whew, that was a lot of work. Yeah, did I make another mistake?
It might be me just confused, but for here with the Z bars above the exponential, and then you took an R out, and then the sign flipped.
Yes. Oh yeah, okay. All right, so cosine of negative phi is, so cosine is an even function. So if you put in a negative phi, it's the same as putting in a positive phi.
Okay.
And so if I put in negative phi here, I get the same output over here as if I put in negative phi gives me positive phi. So this one changes this way. Right, so that's what puts the minus sign up. And then I factored this R.
Is that where you said the z bar equals the RE? Is that supposed to be exponential there, or is that?
Yes, that's yes. That's exponential. Thank you. Okay, there we go. That was just a setup. That was the setup. So here's what I would like everyone to try. Notice this. This isn't immediately obvious. I think the best way to try this is just by experimentation. Remember our goal, which was way over here. Our goal was to write q of t in an exponential form. Well, notice what we've got. We've got parts all over the board. In z and z bar, I've got a's and b's, and we need an a and a b. And oh, and notice that e to the I omega t maybe would fit the form of a cosine and a sine, wouldn't it? But what's this missing if I wanted it in the exponential form? It's missing the I, isn't it? So it's like, wow, it's got a little bit of this, and it's got a little bit of the form of e to the I something, whatever your angle is, something of this nature right here. So here's what I would like you to try. I would like you to take a moment and multiply the following. Multiply, oh, let's do this. I need a name. How about let W equal a cosine and negative t plus b sine negative t. Try ZW and see what you come up with, and then try Z bar W and see what you get. Okay, so take a moment and multiply both of those. See what you get. So you're going to want to use, and I'll set you up. So for example, this first one you're going to use A plus IB times A cosine. Oh, no. Now I gave you, actually, the wrong thing. W is cosine omega t plus I sine. There we go. Let's do that. Yeah. So you multiply cosine omega t sine omega t. Okay, try that.